Good evening. Hello, everyone. Let's start our second class in the course Time Series Analysis. Let me remind you that you have two upcoming deadlines, one due Sunday and for the first DataChem course, and another one due to the next class, I guess. They can be mistaken. If you haven't joined our Telegram chat, please do it now. I'll send join link to the Zoom chat. Yes. Do you have any questions regarding our previous class? No questions. Let's continue.
Sorry, more about the second deadline, because I don't remember that we discussed it. Maybe just because I don't remember. But anyways, can you just repeat it, please?
What? I didn't hear your. Could you repeat your question?
Yes. Can you please tell more about the second deadline? Because the first is the deadline for course on DataCamp, and the second one I don't remember. Can you please remind?
Yeah, of course. I'll post the first home assignment on Monday. Okay, it will be similar to our tutorials, so to our seminars. So it will be a notebook which is partially filled. So you need to, you'll have examples, and you'll need to change some parts of the code so to finish this home assignment.
So will it be individual or group work?
It is individual home assignment.
Okay, thank you.
So let's repeat what we've done last time. We split data into train and test in order to apply two naive forecasters, constant and seasonal ones, and ETS model with additive trend, error, and seasonality. Moreover, we visualized time series using a function plot series from skTime and plot from matplotlib. During the lecture, you discussed stochastic processes, its properties, weak stationarity, white noise process, functional form of ETS, and point and interval forecasts. Today, we will talk about ETS model estimation, about coefficients in ETS model, and like how to estimate it, how many coefficients do you have, and so on. And we will use our ETS model to perform simulations. And at the end of our class, we'll discuss commonly used forecast quality metrics. If we have some models, how to choose the best one. So, okay, let's begin. Import necessary modules and functions, as well as like our data. We'll use the same data just for simplicity as in the first class. It is called load airline from SKTime datasets. I'll check it. I'll send you this notebook now. So you can see a lot of versions in our Telegram chat. But please use the last one. Yes, we import yes, this function. So let's use y instead of plot airline and plot this series. So it should be familiar for you. So we used it last time. And let's repeat some steps. For example, test and train split. We split our data into two parts.
Sorry, can you please turn on your screen because we see nothing right now?
Oh, sorry. Do you see my screen now?
Yes, thanks.
And did you see like previous from what part you didn't see my screen? Ah, okay, sorry. I haven't checked it. Oh, sorry. Let me repeat quickly the first two steps. We upload data function to plot time series. We assign it to new variable and plot it. It is from the first class. Then we split the data into train and set and test. We choose the following horizon, or we can call it as the size of a test sample. And let's estimate ETS AAA. As you know, it stands for additive error trend and seasonal. Import function out ATS. And define it, choose appropriate specification and seasonality period. As we already discussed, our data is monthly data, therefore we should use k-value proportional to 12. Then apply it to train set, get results, and plot. Now let's learn something new. But first, let's revise our knowledge. Let's what do you mean by Konstantin? What do you mean by beta model? Yes, for example, you can use methods from machine learning, for example, random forests and so on. I think it should be much better, and we will discuss it later. And moreover, you can use ARIMA models, and I think machine learning models are the best ones. TS model by hand. Sorry, what do you mean by hand? So you want to choose parameters of ETS model and use these parameters instead of Rima and auto Rima. Okay, I understand your question. Let me answer it later. Sorry, I can't answer it now. Let's return to ETS models. We can write ETS as plus like level component and seasonal component. Where level component is the previous level plus growth rate. And seasonal component is modeled as is modeled for monthly data. Oh, sorry. Yes, and now let's substitute it in the first formula, and we will get that YT is this one plus plus this part. Now I have a question to you. How many parameters we need to estimate in this in this system of equations? Okay, 5. So let us calculate. We have 12, right? Plus 2 initial trend and level. plus 2. First one is L2, L0 and V0. And 12 is like S0, S minus 1, and so on until S minus 11. Yes, good question. Yes, we can get just a second. Yes, you're right. Sorry, I made a mistake. So let's open the lecture. Yes, you're absolutely right. That's, okay. Why some of you obtained 15? And now let's add noise term to each of these equations. So it has a different impact on each of them, and that's why we use like this different coefficients. Should be here. So if we add random terms to all of these equations, how many parameters we need to estimate? Our new parameters are alpha, beta, gamma, and sigma, plus plus 4, right? Plus 4. Right. I think it should be 12, because we need to model this. Sorry, I can't explain it now, but we need like this. We need. Okay, so we estimate. I confused a little bit. The model estimates all 12 components, but one of them equals so it expresses one component as from this equation. You're right, but let us write 12 plus 4, and we will get 11 plus 4. 17. And 4 components are alpha, gamma, and sigma. Don't forget about variance of the random term. Okay. Now let's get estimated all of these coefficients from our model. We need to use the following code: ETS AAA. Oh, sorry. Forecaster summary. It is the name of the model. We define it here. If you change the name of the model here, you need to use the same name later. So let's look at it. We have the first 3 components. It is alpha, beta, and gamma. Maybe in another order, but level is L, trend is B, and seasonal is like this one, gamma. And initial level L0, initial trend B0, and 12 initial seasonal components. Okay. Let's continue. Unfortunately, we can't use this output as a table because this function uses summary as I don't know how to explain it, but it obtains this result without as one object, and we can't separate it, these parts from it. But we can do it. How can we do it? We can use module inspect to see inspect get source, and here auto ETS summary. Auto ETS uses this method to calculate to get this table, and to get, for example, this kind of coefficients, we need to use ETS our model, and then use a part from here. For example, if we add summary, we will obtain the same summary, but this summary, we know that this summary is not this part was skipped here, and it was the reason why we cannot, for example, retrieve coefficients from the summary. For coefficients, let's use params, and you see we have params params, and to understand we want to retrieve not only coefficients, estimated coefficients, but also their names. Because from this output, we don't understand which one is initial level, which one is trend, and so on. So we want to create a table with parameter names and parameters. Oh, let's do it. That's not the only thing they can do. Let's find something interesting here. For example, we can confidence intervals. Yes, we can obtain confidence intervals for each variable. Just for like smoothing level, smoothing trend, and so on. Or what else? This one is interesting because if you use ndoc, you actually obtain your initial time series. So if we plot it, we will get the same. So it is our time series which we analyze. We can experiments. We can get forecasts. Inside, we should specify forecasting horizon. For example, if you want to get one step ahead forecast, use step equals 1. Step, it should be n steps. Not step, steps. And okay, if you are interested in 2 steps ahead forecast, change 1 to 2. We use ETS models. It means that we decompose a time series into 3 parts, and so the model estimated as the structure of our time series is as follows. And it means that we can decompose our time series into seasonal part, trend, and we can obtain residuals. Let's do it. This is our time series. Let's plot trend. And trend is called level. Plot series. So this trend. Let's plot seasonal component. To do it, use season instead of level. And be careful, because if you use trend instead of level, you'll obtain like a specification of the model, or see, the same works for seasonal. Yes, check that you used the right method. What else? And the third one is Residuals. Okay, and let's let's obtain what is left after 3 steps decomposition. Oh, let's just remove effects of not effects, trend, seasonality, plus season, trend, season, and where is it? Is it? Trade not container loop. Why? Level and plot. Let's plot it. So if model specification is correct, we need to obtain a white noise. And to check it, we need to use different. We can use different tests. Maybe we will use them later, but not today. Simulations. Now let's proceed this interesting part of our class. Let's use ARIMA ETS similar function also to for ETS model estimation, but this one difference. We can apply simulate to this model. For auto ETS, it is not implemented. And that's why let's import this model. Use necessary seasonality period, specification of the model. Everything is the same. Fit it and simulate. Ensure is a part of it is to explain it. It is a point. It is an observation when we start to apply our simulations. That means that we start simulating. Simulating after, after the end of our period. And it means that we will perform simulations for 2 years and make 100 repetitions. Okay. Now let's get interval forecasts for each observation in our forecasting period. To do it, use this name. Like for example, if we remain it, we should use the fit the same name. Fit to get prediction. Get prediction. Start. Let's start from here, and end is it should work, and represent it as a pandas data frame. Summary frame. This value means that we want to obtain 95% confidence interval. It means that this mean forecast is always inside this interval, and we will obtain, for example, this is a forecast for the next period, one step ahead forecast, and we will we will obtain a value in the future which will lie inside this interval. For example, in this case, it is more general approach compared to point forecast, because point forecast is just one point, and interval forecast is not it's not only one point, but also interval for 95% confidence level. Okay. And now we can, yes, it works. We specified forecasting period as so let's change it to 2 years. Yes, and now it is the same as test sample. Let me find plot this one. Konstantin, what function and module do you use? Could you send a screenshot the Telegram chat, or maybe you want to share your screen? Okay. Matplotlib. Use change the first line. Instead of matplotlib, use matplotlib.pyplot. I'll show you. Where it is, import matplotlib dot pyplot as plt. So add this this part. Last time we got this point forecast, and now we add to this point forecast intervals, 95% confidence intervals, and plus for the period from our last observation, we make a simulations 100, if I'm not mistaken. Let's check. Yes, 100 from the last observation, and we obtain the following picture. And inside this period, we cannot compare our result to true data. We don't have it. This is our last observation, and we use this test interval to get the best model and then use it for the future, for the next periods. What else? About quality metrics. There are a lot of different quality metrics. I'll provide the most commonly used ones. For example, mean absolute error. From the name of this function, you can guess that absolute means absolute value of the difference between true value and our forecast, and this, we sum across our forecasting period. Very similar metric is mean squared error, but instead of absolute value, we use the second power. And another metric is mean absolute percentage error. And for this metric, we need to divide by observation. Yes, and multiply by 100 because we want percent instead of value. For example, 0.2 is 20%. Like to use these functions, you can code it by hand, or you can import them from sklearn metrics. To do it, just import from sklearn metrics, import now names of functions. And now we can use it, them. There is no mean absolute percentage error function in this module, but it can be easily coded. Just use this code. This def means that we define a new function, which is the name of the function, and in brackets we use the inputs and return this like this value. It is very easy. Now I suggest you do the following task. Like choose a time series. You can choose any time series you want. I suggest the same time series as at the first class, but you can find another ones. And specify forecasting horizon. I choose appropriate ETS. You can try different specifications of ETS. Then obtain 95% interval forecast. Get parameters, and then decompose the time series into trend and seasonal components, and then perform simulations. So you can skip some of these steps if you don't want to obtain parameters or something else. Just don't do it. Yes, it's time to practice. Okay. And I'm ready to answer your questions if you have them. I sent this notebook to our Telegram chat. Next time we will study cross validation for time series. So we can't apply this technique for cross-sectional data because the structure of time series, no, we cannot shuffle this like test and train sets as we want. We need to just let me find it. We need to have the first part as a train set and the next part as a test set. Yes, we need to have the following structure. What else? Okay, if no questions, then let's say goodbye. Do not forget about like your deadlines. See you next time. Write your questions in the Telegram chat. Okay. Thank you for attending this class. Okay, bye-bye.